This paper is about a collaborative project between technical researchers, who are shown in black for the black aspects, and nutrition researchers shown in the purple. And the driver for our work was that every year there are many health studies that evaluate the way they can use UbiComp technology, but they miss the opportunity to learn about more than health and to gain rich technical insights. So our context was a public health nutrition study where we wanted to understand just what young adults eat in Australia. We are funded by the Cancer Council, which reflects the importance of nutrition for health risks. And our nutrition researchers really needed very detailed records of what young adults ate over 3 days that they volunteered to log their food intake. Well, the challenge is that detailed food logging is very, very tedious. It's also error-prone. And so we set about tackling the challenge of building an app that would really make it easier for people to search, to find their food in a large food database. And they had to do this on a very small mobile phone screen. So we created this Eat app, and you can see it on the screen. And one really important aspect of the search is we started with the intuitive idea that the top 100 foods that are most frequently eaten would actually be really important, not just because they should be easy to log, but also their words would be useful for generating a way to help people search for other foods. And so our algorithm generates these search accelerators to help people narrow down their search. But then how could we evaluate it? And we wanted to do that by making use of our multidisciplinary collaboration. Our collaborators, the nutritionists, recruited over 1,000 participants, and they created a database with over 6,000 foods. And to give you a sense of the challenge of the search, here is a glass of milk, and there are many entries that match the word milk because there are different fat levels, and some of it's plant and animal and so on. And our participants over their 3 days logged over 30,000 food items. So what was our approach to using all of this to learn about how to do a better job of building this technology? We identified some key benchmarks, and we then worked with our team to find a way to measure them. So here's a taste of the benchmarks, full details in the paper. The first one is timeliness. That's really important because the mobile app was supposed to enable people to log their food through the day as they ate it. It's really important because it reduces the risk they'll forget it. It's also important because the burden of logging is then spread through the day when they have a few moments to spare. So here's an example of one of the benchmark visualizations. The top row is breakfast, and you can see there's a heat map here where the more logging that's done, the more likely it is to be a bright green. And you can see the top row of breakfast has a lot of green in the breakfast period. We translated this into some measures which would enable you to compare various apps for timeliness. The second example is much more multidisciplinary. We wanted to understand search failures when people couldn't find a food in the food database. Now, Eat allows you to add a food when you can't find it, and we analysed over 1,000 of these. I have to emphasise this was only useful because the nutritionists had cleaned up all this data. They often had to make a phone call to clarify things with the participants, and then we analysed all of these mapped foods to understand what the cause of the failure was. And you can read the details in the paper. The highlight is our search did pretty well. Not all the benchmarks came just from the field trial. We also wanted to know how long it takes people to log a typical day's food in terms of the time burden. Our nutritionists designed a typical day of food, And then we ran a lab trial where we looked at how long people took to log it and collected other qualitative data. This is a really important measure, and it should be reported for every app of this type. We believe that all of our benchmarks are either directly useful for comparing apps, but also reflect an interesting approach to doing similar analysis. Our contributions are a novel food search algorithm and method, but also the evaluation benchmarks that we developed, the way that these could be used in many health studies by repurposing the work of the health researchers and giving UbiComp insights. So we've provided foundations for systematic evaluation and benchmarking of a mobile food logging app, and hopefully as an inspiration to others.